Hello everybody. In this video we're going to take a look at Maya's nCloth, an introduction to nCloth. So the first thing we'll do is to create a piece of geometry that we can use as our nCloth example, and we'll keep it very simple by simply making a polygon plane. I'm going to scale it up a little, make it a little larger. Oh, maybe something like that. I think I'll go ahead and freeze the transformations on it. And actually, under its inputs, I'm going to bring down its resolution. Perhaps something a little more like that. Duplicate that, move it over here, and then we'll take the original one and we'll increase the polygon count on that one, or the subdivisions on that one. I'm going to turn on shading wireframe on shaded so that you can see this a little bit better. And we'll go ahead and bring these up on the y-axis like this. So we have our two polygon planes, very similar to one another. The only difference really being that this one here has considerably more geometry than this one here. Now to make these nCloth examples here, it's very easy. We'll simply select them, go to our effects menu set here, and then go to nCloth, create nCloth. I'm going to make sure that my playback speed is set to play every frame. This is necessary. Just like with the N particles, nCloth also requires that the calculations are done on every single frame, requiring that we make sure that we play back every frame. So I'll go ahead and save that, and let's go ahead and play the simulation. So they're both working as nCloth examples. However, it's pretty boring right now because they both simply fall down due to gravity, but nothing else really happens. Let's make this a little bit more interesting by creating something that these nCloth objects can collide with. So we'll just make a very simple cube for it to collide with it. Perhaps something like this. In fact, I'll go ahead and create two of them. And if we play the animation here, you'll see that nothing happens yet because we haven't told these objects to be passive colliders yet. So I'll select both of my objects here. And once again, I'll go to nCloth, but this time we'll choose passive collider. And we'll play the animation. So as you can see, we got two very different results here. And the thing to take note of is that the one with more geometry gave us a much better simulation of cloth than the very low resolution one. So this is something to keep in mind when using N particles. Just like when you are creating a character that's going to deform through rigging and a skeleton, you need to have the geometry for that deformation. You'll also need more deformation for creating realistic cloth effects. I'm going to delete this passive collider here, and I'll delete this nCloth object here. And let's try creating another passive collider, but this time we'll make something of a different shape. So I'll move this one out of the way, and we'll try something more cylindrical this time. Once again, I'll select the object that I want to make into a passive collider, and I'll go to nCloth, Create Passive Collider. Make sure when running these simulations that you rewind. In other words, you want to be starting at the very beginning of your timeline on frame 1 and then hitting play. And that gives us quite a nice result. Now, perhaps to make this stand out a little bit more, we could go ahead and apply a texture to it. And this is very simple to do because this is a simple polygon plane. So its UVs are very uncomplicated. We could apply an image as a texture to this very quickly, very easily. But for this example, I'm simply going to make a tablecloth texture using a ramp. So let's go ahead and create our ramp here. I'm going to call it tablecloth. And we'll go to its color channel. And for this example, I'll use a ramp. Let's go ahead and make sure we actually apply it to our tablecloth. Press 6 on the keyboard so that we can see what we have here. You can see as I adjust my ramp, the texture adjusts on here as well. I'm going to change the interpolation from linear to none. Perhaps we'll play around some with the color here. And instead of going on the V ramp, I could go on the U ramp, or in this case, I'm going to try the tartan ramp. Perhaps we'll make the texture repeat. And here is our tablecloth texture. Let's go ahead and play the simulation again. And here's what we've got. Now, in our Maya scenes, we don't always want to start with the tablecloth above the surface it's going to rest on and then have to play it and have it drop onto the surface. We might want to go ahead and pick a different frame. In this case, I stopped it on frame 108 and have this be the starting point for our cloth simulation. So we can do that. I have my tablecloth selected right now. And what I'm going to do is go to Fields, Solvers, Initial State, and we'll choose Set for Selected. So we have the tablecloth selected as the object, and we're going to choose this state as its starting position. So if I click on that and then I rewind, you'll notice that it didn't go back to that position of it elevated above the surface. So now it no longer needs to drop and fall onto the cylinder. And if we play it, we'll get a little bit of movement here, but otherwise the tablecloth rests on the surface very nicely. Now, because the nCloth exists in the same dynamic system as the nParticles, just like the nParticles, it's able to use these passive colliders, and also, very importantly, it also utilizes a nucleus node. In fact, it can utilize the same nucleus node that your nParticles is using. meaning that your nCloth can actually interact with the n particles as well. Let's select the nucleus node here and take a look at some properties, or a property at least, that we can change in here. So I currently have my nucleus node selected. I'm going to rewind, and we'll try out the wind speed here. Currently it's set to 0, so there is no wind in our system here. Let's go ahead and increase our frames here so that we have a little more time to work with. I'm going to increase it to 500 frames. We'll play the simulation, and I'm going to bring up the wind factor. You'll notice that it's having an effect already on it. In fact, it's so strong that it's blowing the tablecloth right off the surface. Let's rewind that, bring that wind speed down a little bit. Currently I have it set to a little bit over 10. We'll bring it down to 5, or around 5, and try that out. Once again, you can see that it's sliding off of the surface here. So what can we do to make sure that the tablecloth doesn't blow off of this surface here when we play our simulation? Perhaps I like this level of wind, but I really don't want the tablecloth sliding off as it's doing right now. There are a couple different ways that we could accomplish this. So the first way is we could select the tablecloth itself and look at its properties. So currently I have my tablecloth selected, and in the attribute editor I'm in the nCloth shape 1 tab. And what you'll notice is, similar to our n particles that we looked at in earlier videos, we have some of these various properties. And the two that I would like to take a look at are friction and stickiness. Either the friction or the stickiness could be a solution to keep this tablecloth from sliding off of the surface here. Let's go ahead and try friction on this tablecloth. We'll simply crank that up, rewind, and play. And that seems to have solved the problem of the tablecloth blowing off of the surface. Now, before moving on, I should also mention at least that for the passive colliders also, we could select those, and they also have their own friction and stickiness property too, which we could also adjust if we needed to make sure that this tablecloth wasn't blowing off the surface here. Let's take a look at something else here. I'm going to return to the nucleus node and go back to the wind and just talk a little bit about where the wind is coming from. So currently what you'll notice is that the wind direction is set to 1 on the X. These three values here indicate X, Y, and Z. So in this situation here, the wind is actually coming from the X direction, which you can see here, the X direction, X positive meaning that it's going in this direction like this. Coming from here and going in this direction. If we wanted to reverse that direction, we could simply put a value of -1 on the X, and then the wind will come from the other direction. To make this a little more visible, let's increase the wind speed. And of course, if we wanted to, we could change the direction altogether and have it blow on the Z direction. This time, it'll be blowing from here and in this direction. Or maybe we want the wind blowing up. I'll increase the wind speed again to make it a little more obvious. And there it goes. I'm going to set the wind speed back down to a smaller value, and I'll make it go on the x-axis once again. Now what if I wanted to recalculate this because I actually don't want it to interact with this cylinder? We'll go ahead and move the cylinder off here and perhaps move our cube back and play it. And actually, I'm surprised at how well that worked. But what I'd recommend doing in this situation is selecting the nCloth itself, going back to the fields and solvers, initial state, and clearing the initial state, playing the simulation again, perhaps getting it a little more like something we like. I'm going to bring this down a little further so it's not having to drop from as high a place. Drop it. And perhaps we can keep this now as our new initial state. So I'll go once again to field solvers, initial state, set for selected. I'm going to go ahead and clear that one more time. We'll go ahead and go to the initial state, clear initial state, and I'm going to move my cylinder back over there. We can run our simulation. Perhaps I'll bring the wind down by selecting the nucleus node, and we'll just bring that wind speed back down. And what I want to show you here is how you can duplicate a mesh. For instance, if I hit Control D, I can duplicate this mesh. And the thing to realize, however, is that it will not be an nCloth. It is simply a polygon mesh. You can see that if I play this, that it in fact is not calculating or moving in any way, unlike the original nCloth example here. But this could be a convenient modeling tool for, let's say, if you're creating a scene, a cafe type scene, and you don't necessarily need to have these nCloth simulations going on. You simply need to create the scene here. This would be a very convenient way to model a tablecloth. Let's take a look at another example of an nCloth object. This time we'll make a flag. So once again, I'm going to start with a polygon plane here. And we'll go ahead and maybe increase its width. And we'll increase the subdivisions as well so that we have a little more to work with. Not that this is super important, but I'm going to go ahead and just roughly try to make them square. That's not absolutely necessary, but you can see that I've adjusted my subdivision width and height to different values to get that more square geometry there. Again, I wouldn't focus too much on that, however. And once again, we'll go ahead and create a material for this. And since we're making a flag, but we want to keep it very simple, we'll pick a flag that's not too complicated. Perhaps we'll do a ramp again. Make sure we apply that ramp to our object. And we will do none for the interpolation, and we will have 3 colors on it. And instead of V ramp, let's do the U ramp. And we'll give it some colors here. So here's a flag. I'll just make a few more adjustments to it before we make it into a cloth object. And there we go. Once again, I'll select the object that I intend to make into an nCloth object. Making sure that I'm in my effects menu set, I'll go to nCloth, create nCloth. Perhaps give this a few more frames, and if we play our simulation, our flag drops. So this time we want a little bit different behavior than the tablecloth example. So let's go ahead and make a cylinder, which will be the flagpole. Position it in place. Perhaps something like that. While I'm at it, I'm going to move my pivot point for this flagpole down here. That way, if I rotate it, it'll be more from its base rather than from the middle of the flagpole. And we'll go ahead and create another passive collider for this. So let's go ahead and do that. With the flagpole selected, go to nCloth, create passive collider. So now that we have our flagpole and our flag, let's see how we can attach the two. I'll select my cloth object, and I'm going to go into component mode, and I'm going to select these vertices here that are close to the flagpole. And I'll shift select to select the flagpole itself. And we'll go to nConstraint, point to surface, and apply. So now, if we play this, the flag is attached to the flagpole. That's a little bit underwhelming, however, when the flag just kind of droops down as it's doing now. So let's add some wind to this. Once again, I'll select my nucleus node and we'll increase the wind speed. Perhaps try a value of 5 first. We'll go ahead and keep it on the direction for the wind on the x-axis, so it should be coming from here and blowing in this direction. And let's go ahead and play and see what we have here. Perhaps we need to increase that wind speed. And there's the flag blowing in the wind. So let's take a look at another thing that we can do with these nCloth simulations, and that is to actually animate our passive colliders. So for this example, I'm going to select the flagpole that we have here, and I'll go to perhaps frame 100, and I will key it. 20 frames later, we'll go ahead and rotate the flagpole like this and key it. Go a few frames later, rotate it back. We'll have the flagpole continuously moving back and forth like this. So I think I'll just actually copy some of the animation over and simply paste it. Okay, let's see what we have now. And before wrapping up this video, we'll take a look at one more example of nCloth. So for this example, instead of using a flat polygon plane, we're going to start out with a cube, and I'm going to put a mesh smooth on it and add the divisions just so that I have a little more geometry on it. Something like this. Perhaps I'll scale it up a little larger, and I'm going to go ahead and freeze the transformations on it. So I'll raise it up a little above the ground plane here. And once again, go to nCloth, create nCloth, and we'll apply. Let's play the simulation, and the surface drops. I'm going to select my nucleus node and go to the attribute editor, and we'll tell it to use plane. That way, the nCloth will collide with the plane down here. And there's what we have. Now I'm going to select the nCloth object itself, and we'll take a look at some of its settings in the attribute editor found here. We're in the nCloth shape 1 node. And as we noted before, we've got some different properties such as friction and stickiness on here, as well as a lot of other dynamic properties that we can adjust. Now I find that the simplest way to work with nParticles, however, is to use Maya's presets. And these presets can be found here. So with my nCloth selected, I'll go to presets and notice that we have a lot of them. Let's try beach ball. So to apply the beach ball preset to my nCloth object, I simply go to beach ball and then click on replace. And that will replace all the properties, the current properties on my nCloth, and apply the beach ball preset properties to it. So if we apply that, notice also actually that it gives us a description after applying that preset. It gives us a description of the behavior that this preset will have. So we'll go ahead and play this. And there is the beach ball behavior. Notice how it's actually inflated the geometry. Not exactly the most convincing beach ball in my opinion, but a lot of that has to do with the scale that you're working at in Maya. To actually get things to behave properly, it's very important to understand this concept of scale in Maya in 3D space. Now, what do I mean by scale? Well, for one thing, if I were to go to my Windows General Editor's content browser and drag in one of these human characters, that would give us a sense of scale, and you can see how large this character is relative to this polygon sphere that well, this was actually a polygon cube, wasn't it? And I did a mesh smooth on it. If I actually created a polygon sphere, it would look roughly the same. Here's a polygon sphere. But this gives you a general sense of scale by dropping in this character in here. Another way that we could consider scale would be if I were to create a cube, and by default Maya's units of measurement are set to centimeters. So if we're talking centimeters, this cube is 1 centimeter by 1 centimeter by 1 centimeter. So in fact, it is about the size of a sugar cube. Another way that we could look at scale in Maya would be to go to Create, Measure Tool, Distance Tool. And then we can use this tool by dropping these locators in here to measure the distance between any 2 points. Currently, you will notice that between these 2 locators, this locator here and this locator here, I have a distance of 7 centimeters. Now the fact is, however, that when we're working in Maya, oftentimes we're not really all that concerned with scale as measured in Maya. What's important is that if you're working on a team, that everybody is working at the same agreed on scale. The other thing that's very important to understand in Maya is that even Maya is not entirely consistent with this sense of scale. So sometimes your dynamics that you work with in Maya may be working at a different scale than what you're actually modeling in. even if you're modeling at 1 centimeter being a centimeter. In other words, if you use Maya's scale of centimeters to measure things and get them appropriately sized, your dynamics still might not work as you expect them to. But fortunately, there's a very quick and easy way that we can scale these effects in Maya to get them to work as we want them to. And to do that, you select the nucleus node, open up its attribute editor, and find the scale attributes properties found here. And as you can see, we can scale either time or space. So let's take a look at what we have here with this ball falling down that we've applied the beach ball preset to. And if we play it, here's how it behaves. Let's see what happens if we adjust space scale. So currently it's set to 1. Let's go ahead and set it to 5 and see what effect that has on this simulation. And perhaps that's too slow. Let's try speeding it up this time. Remember that the default value was set to 1. What would happen if we set it to 0.25? And as you see, we get a different result. It is now working faster. I'm going to set it back to 1, and we'll take a look at some of the additional presets that we have available with nCloth. So once again, I'll select my nCloth example, and we'll go to presets and choose some of these other ones. Let's take a look at solid rubber. I'm going to replace the beach ball preset with solid rubber. And I'm just going to replace it 100%. So let's see how it behaves now. And as you can see, that gives us quite a nice result. Nice sense of squash and stretch there as it hits the surface. An interesting way to work with these presets, though, is to, first of all, explore and experiment them. Take a look at concrete, for example, and maybe contrast that with heavy denim. Or perhaps honey. And the interesting thing is that we can even combine these presets. So currently it's set to 100% honey preset, but we can come to our presets and, for instance, go to water balloon and maybe blend it 50% with water balloon. And don't forget that you can take these nCloth examples and have them interact with your passive colliders. So before wrapping up this video, I'd like to just re-emphasize one more important point. Just like our N particles, you cannot scrub in your timeline, as I'm doing now. You can see as I scrub in my timeline, nothing is really happening, or what we're getting is not exactly a predictable result. You need to rewind and then play, and you should make sure that you are playing at every frame. In other words, in your playback settings, make sure the playback speed is set to play every frame so that each frame is being properly calculated. But similarly to the N particles, what we can do is create a cache. So I'm going to rewind, select my nCloth object, go to nCache, create new cache, nObject. It will go through the simulation, making all of the necessary calculations. And then when it's completed the operation, you can scrub backwards and forwards in your timeline. Understand, however, that you cannot go and then change the properties of your nCloth object at that point. Basically, the animation has been baked into the simulation. In fact, to demonstrate that, let's go ahead and just move this passive collider here and scrub in the animation, and you'll see that it's animating as if that passive collider were still there. This is very valuable for if you are animating a character, for instance, and you need it to interact with these kinds of special effects, and you need the special effect to behave consistently, and you don't want it to have to go through all of its calculations all the time as you're working. So you can see that because I've moved this passive collider, this object is not interacting with it any longer, not interacting with it appropriately. If I made these changes and then I wanted my nCloth object to interact with it appropriately, I would need to select it, go back to nCloth, and delete the cache. Now, when I play it, it'll interact with the object once again. Anyway, I hope that this video will help you get started using nCloth in Maya. Thank you for watching.